This is the Smart Lighting System demonstrator built jointly by the TUE Sun Department and NXP. This is the TUE Sun lighting system, which is based on OSAS framework. The lamps with actuators are connected to the light KP, and this KP is then further connected to the SIB. The wireless sensors are connected to the KP also for updating light intensity in the environment. The OSA system offers a number of possibilities for intelligent lighting systems. For example, here we see lights that can adapt their intensity based on the environmental conditions using the sensor data. The NXP lighting system consists of sensors that can detect presence by motion detection and light intensity in the environment. Here you also see two light KPs that can change lighting conditions in the environment. These light KPs can also measure energy that they consume and report it to the SIB. A switch is shown here that runs on a laptop. Binshi comes into his living room. The lights come on when he is detected. Binshi wants to read. He finds it too bright to read, so he turns the lights to a lower level, to 50%, and reads comfortably. After some time, he leaves the room for a while, and the lights turn off. Later on, when he returns, the lights come on again, but at the level that Binshi had selected before. This is a scenario in a bedroom. When two persons enter the room, then the lights turn on. When they decide to go to sleep, they switch on the night mode. In this mode, the lights dim down to 10%. When they fall asleep and don't move, then the lights turn off. During the night, when one person wakes up, the lights turn on but at 10% level. This way, the other person who is still asleep is not disturbed. Now we present the interoperability scenario based on Smart M3. Companies are thinking about new business models to better control their grids. They would charge more rates for energy if an agreed quota for a building is not met. This demonstrator shows two rooms in a building. The lighting system in a high priority room uses as much energy as is needed by the user for his comfort. A low priority room uses the leftover energy such that the quota of the building is maintained. The main goal of this demonstrator is to show two different lighting systems based on different architectures interoperating by using SOFIA M3. Here we show the system architecture where on the left side a low priority room based on TUE's OSAS architecture, and on the right side is a room with high priority based on NXP's own lighting system. Interoperability is achieved through OSAS knowledge processors and NXP knowledge processors with the SOFIA service information broker intermediating between them. The NXP knowledge processors tell the TUE knowledge processor how much energy is consumed in the high priority room. The TUE knowledge processor maintains lights in the low priority room such that the quota agreed with the energy company for this particular building is respected. So here we have the SIB that is connecting the low priority and the high priority room. Here we see the high priority room with NXP sensor and the two light KPs, and the switch which is running on a laptop. Here we have the low priority room where the TUE OSAS system is running. Sachin wants to read in the high priority room. He finds that there is not enough light. Sachin turns the lights up so that he can read. The lights are now consuming more energy in the high priority room. In the meantime, the lights in the low priority room get this signal through the SIB and start using less energy. After some time, Sachin is done reading. He turns the lights down again. The lights in the low priority room can now consume more energy, and they start going up. When Sachin wants to go to sleep, he turns on the night mode. The lights in his bedroom go off after some time, and then the lights in the low priority room can start going up and consume more energy. We have demonstrated two different lighting systems that are based on two different architectures and also implemented on different device types. We show that these architectures can interoperate by sharing semantic information through the use of Smart M3. Thank you for your attention.